Problem 134, gas station. In this problem, we have a number of gas stations arranged on a circle. So this is a gas station. And each gas station has two numbers associated with it. One is this one that I've shown in green, and this is the amount of gas that is available at this gas station. And the other one I've shown in red, this is the amount of gas required to get to the next gas station clockwise. So these are given inside arrays that are named gas, so gas and cost. Now these are function parameters, so we could freely rename them. So these are arrays basically. We also have a car, right? And with this car, we're going to travel around all of these gas stations clockwise. Initially, our tank is empty, but tank is infinite. It can take any amount of gas we put in it. But initially, the tank is empty. We have to find a starting position, an index of the gas station, such that if we start there, we would be able to travel around all of the gas stations and complete full circle and arrive back to the starting gas station. If such an index exists, we should return such a starting index. Otherwise, we should return -1. We are assured that if such a path exists, then it will be unique. So if there is a solution, it's guaranteed to be unique. I don't think this is particularly useful to us. Maybe it's useful. Maybe they have specific solution in mind. I don't see how this is particularly useful. So the solution I'm going to propose will find a path, whether it's unique or not. So first observation is that these two numbers that are given to us are roughly the same in nature. So this +1 is the amount of gas we will get while passing through the station, and this is a negative amount of gas that we will basically lose while passing through the station, provided that we're going to reach the next station, right? So in some sense, we're mostly going to be dealing with the delta here, the gas minus cost. And that will be the net benefit from passing through that gas station. So that benefit could be positive or negative. Okay, so I would propose that we do something like that, the following, just to come up with some sort of algorithm here. Let's have a couple of variables, start and finish. Now, initially, start and finish would both point to, let's say, index 0. And let's also have variable tank, which will basically track the amount of gas that will be left in our tank when we reach the next gas station. So if our finish is pointing to, at some point, pointing to the station, for example, what tank tells us is how much gas we will have in the tank when we reach the next gas station, the next one. And then, because this is slightly unusual, why tank points the amount of gas at the next station. Well, this comes from the nature of this tree. If we want to unite these two numbers, and talk about the delta, then this 3 only comes into effect once you reach the next station. So that's the reason why I'm defining the content of this variable to mean the amount of gas in the car after we reach the next gas station. Okay. So here is roughly what I'm going to do. We start with start and finish pointing to the same point. Now, we're going to calculate tank. That will be, so gas minus cost. And it's some number. In this case, it's -2, right? So if it was non-negative, then we could continue travel, right? If it was non-negative, that would mean we can actually reach the next station, because then the tank would be non-negative. That's a valid scenario. So if tank would be non-negative, we can update finish to point to the next station. But if tank ends up negative at some point, we cannot move to the next station. So we cannot move finish clockwise. So what we'll do is we'll move start counterclockwise instead. So we'll say, well, we can't continue from this point, but what if we had started earlier? What would have happened if we had started earlier? Now, if we started slightly earlier, 1 gas station earlier, then this delta would come into play. So this is +3. So that +3 would simply be added to our tank, right? And if that is enough to bring our tank to non-negative value, then we could now go back to moving finish clockwise. So moving to the next station. But every time tank goes below 0, we will try to add one more. So we would move start counterclockwise. Okay. Now, this sounds plausible only if the following happens, right? So it looks like moving finish clockwise without algorithm is fine. So every time if we have enough gas to reach the next station, that's the only time when we move to the next station. But what happens when we move start to the earlier position? I mean, that kind of changes everything, right? So that means potentially somewhere along the way now, we should recalculate at every gas station. Did we ever run out of gas somewhere? Now, my argument is that we actually do not have to do that. And here is why. Let's say maybe I should just create a new circle and show it on a new circle to avoid clutter. So that's a horrible circle, but let's say our start is here at some point, and there are certain gas stations along the route, and our finish is pointing to this, right? And this is the moment when our tank went negative. So it's under 0. So that means we cannot reach the next gas station. This next gas station is problematic. Reaching there, we can't do that. So let's say we moved start slightly earlier. We moved start here. Let me change to a new color. So this is a new start. And let's say, well, we added this delta, gas minus cost, but this did not bring our gas in the tank in here sorry, at the station. No, actually this was correct. So this didn't bring our tank above 0. That means we still can't arrive to the next station. So we add another, and perhaps another and another station. So start is now here. This is a new start. This is old start. This is new start. And let's say at this point, suddenly, our tank goes above 0. So it's greater or equal to 0. And this happens the first time, right? Well, before this happens, before we go to 0 or above, there is no point in checking any of these points because our path is invalid, right? It's invalid at this point. So there is no point in checking anything and wasting time on this. But as soon as we suddenly go above 0 here, or equal or more than 0, that means suddenly reaching this step has become viable. But what about all of the previous ones? I mean, have we messed something up? Because we've just moved everything. We've changed the start, yeah? Now, I'll show you that we still don't have to check. I mean, technically, we should rerun this route and check everything, that we do not run out of gas somewhere along the way. But I'm going to show you that that would not be necessary. So let's split our path along the previous start. Remember when everything was fine? When we were at start, we first went under the 0 here, and this is where our start was, and now it's right here, right? Our start is now here. So let's consider this point separately. So first of all, I think it's clear that these points have only improved, because all of these points would increase the amount of tank left over when we reach any of these points would only increase, and it would increase precisely with the amount with which this increased. This was negative, now it's 0 or better. So all of these would also be better off. So we can still reach all of the, I mean, all of these trips are valid. But what about here? Is it possible that we ever run out of gas along the path here? And that's also impossible for the reason that, because this is the first time when tank became non-negative, right? When we were moving start counterclockwise, tank went 0 or above for the first time here, right? Now, let's say at this point, if we were to start from this start, and at some point we get negative, that would be impossible. Why? Because then the thing is, that would be the first time when things would get positive. It's very easy to see, because this total is negative, clearly. And then clearly without this, we would be even better. So if with this negative value, we manage to somehow get above or to 0, then obviously without this negative fuel, we would be even better off. So this position would be the first time when we go above 0, not this position here. So that means we are kind of fine. We should be all right with this algorithm. Actually, it means that this is correct. So let's try to implement it. And what we're going to do is, basically we said, set start to 0. Let's say finish to 0. Come on. And we also need, what did it say? We need tank. And let's set tank to 0 here. I will have another variable last. and that would be finish. Well, all of these are basically 0. And the last is the last visited gas station, index of the last visited gas station. And I will need this to just implement this algorithm. And this is how I'm going to implement it. So I'm going to have a while loop. Now, how long should I run this algorithm? I mean, we should run it until start and end, start and finish meet, right? So, but to do that properly, I'm going to set start not to 0, but to an equivalent number modulo n. So gas length, that's our n, right? What I mean by this is I'm going to be decreasing start and increasing finish, so moving counterclockwise and clockwise. So start gets decreased, finish gets increased, and this way, if I set it to basically n, that means it will be, I can never go to a negative value here, right? So modulo n, everything is fine in this, and also start is initially strictly greater than finish. So I could say while start is still greater than finish, I should keep running this loop. I do not need I need a strict inequality here, not greater or equal to, because remember what our tank indicates. Tank means if it's positive or 0. That is basically the amount of fuel left if we reach the next station. So the last time start is greater than finish, this is when the next station would be reaching back to start. Okay, so at that point I have to get out of this loop and potentially check if tank is negative or not, right? And we'll do that a bit later. But while start is still greater than finish, then I have to do the following. So first of all, I have to update tank. I have to say, well, tank will be updated by the whatever delta is available, whatever fuel delta is available at this last station, right? So this would be gas last minus cost last, right? So we've updated tank. Now we need to check if tank is negative. Now, if tank is negative, what happens then is start goes minus minus, right? Start goes counterclockwise, and this goes into last. So this will be the last kind of visited gas station. Otherwise, we would have finish go plus plus because it's going clockwise, so it will increase. And after it increases, so it's a pre-increment. So after it increases, this goes to last. So last will be the correct value, the last visited gas station. Now, why I have introduced last is the following, because I only want to do this calculation only after this is being checked, right? So potentially what I could do is just say start minus minus, and then I could say tank plus equals gas new start minus cost new start. But see what happens here, because I've changed the start. Now start was fine. Start was inside, so no address violation or anything, because this is the so let's say start was fine while we entered the loop, but because we changed the value of the start, now accessing this element could be problematic, right? So I do not want to do this accessing the array after I changed the index. So I can kind of postpone that. get rid of this, simply keep the new index in last. And after I check this, if start and finish are still fine, right? Well, start is new last. So if start is fine, then last is also fine, because after this, start and last are the same. So then I can obviously access this. And why is this enough? Because if you see, finish is 0 initially, start is the big number, right? So last will only become start, which is the big number, only after minus minus. So this means last will never be gas length. The maximum it can be is 1 less than this, which is inside the array. Now, but finish is at least 0, and it can never become negative. It only goes up. So after this evaluation, we are sure, 100% sure, that both of these indexes, start and finish, are fine. And because last equals one of them, then last is also fine. So this should work without any memory violation. Now, once we come out of here, start is the same as finish, right? But the last time we calculated tank was just before that, right? The last time we actually calculated tank was last time we entered the loop, and this is when start was still greater than finish. And we calculated tank, and here we have to check, well, is this a negative number? If it's a negative number, then such a path does not exist. We cannot complete a full circle. But otherwise, we would return start with a little trick. I mean, start could potentially, if start does not change, then it's a big number. It's n. We need 0 instead of it. So we could just take a modulo gas length, right? So if we do that, we should be fine. Let's see if it runs through our pretests. Yeah, these are fine. Now let's submit to the full test suite and see how we do there. Oh, okay, that was nice. So we beat 100% of solutions in terms of runtime. In terms of memory, we did 87%, which is not bad. It's not bad at all. So you know what? I am going to just take this and maybe I'm interested to run this in C++ and see what happens if we were to run this code in C++. So just let me quickly change this to C++, a whole bunch of semicolons everywhere, here and here and everywhere. So length is size, and here it's size. Well, that's our C++, right? Let's try to run it on pretests. Okay, and submit. What's going to happen here? Interesting. Wow. Okay, this is actually, in terms of memory, we have 112 megabytes beating 40%, but with C++, with TypeScript, we had, did we have a better situation with TypeScript? No. Okay, well, no, this is slightly strange. Okay, anyway, that's our solution.